In today's video, we are going to see the solution for diagonal difference problem in the HackerRank platform. So if you are unable to find this question in the HackerRank, please search for this question in the search bar and then you'll get this question. First, let me explain you what is the problem and what we have to solve, and also approach we'll see after this. So first, what is the problem is they'll give us a matrix. So it will have rows and columns, and those rows and columns we will receive as parameters, like how many rows are there and how many columns are there, and we will return we will get the what array elements are also. And what we have to do is we have to calculate the difference of the two diagonal sum. So that means this is the diagonal, means this one, this is the 159 is one diagonal, 359 is one diagonal, right? So what we have to do is first we have to calculate the sum of 159 and then sum of 359, and afterwards we have to subtract these two results. That means sum of 1 plus 5 plus 9 minus 3 plus 5 plus 9. So this is how, and we have to take it as a mod only. Why? Because we don't know which diagonal value will be higher. So even if we get negative numbers also, we will just convert them into positive number using this mod function, and we have to return this difference. So I'll explain you here clearly. So what I'll do is I'll just take 3 by 3 matrix first. Now what we will have, let's take 1 2 3, and then 4 5 6, I'm sorry, 6, and let's remove this ones please. 1 2 and 3, okay, it's 3 6, and then 7 8 9. So let's take this one as example for 3 by 3 matrix. Now what we have to do, we have to find the index. So why I'm telling this, because see in this question what they have given, we have to take the diagonal sum, right? But while we know what is diagonal, but how to represent that in coding, that means we should find the index value, and using those index value we have to add those values. So let me just explain you how. So for these first element, what will be the, let's take the matrix name as A, okay? A matrix. A is name of the matrix, okay? We'll take small a only, okay? Now what will be the position of 1? So we know that the first element will be 0 index, okay? So what is the position of this 1 1 is A 0 0, right? 0 means first one is 0 row and the second 0 is for 0 column, right? This is how you will write the index or position for this numbers. And then what will be the value for this two? A 0 and then A of 1. That means first row and second column, okay? So how you will write this? Let me give some space so that it will be clear for you. Okay, I'm writing down. And what this is, first row, first column, second column and third column, but while representing in the form of index, we'll take this one as 0 1 and then 2. So this is the index position of the two number, and then we will go for 3 now. So what you will write? A of 0 row and then 2 column. That means first row, third column. This is how you have to write the indexing. And then A of first, now one row is completed. That means this is second row. So you have to represent it 1, A of 1, 0, because this is the first column. So how you'll write for 5, A of 1, 1, because it's second row, second column. So that means you have to do minus 1, since we start the indexing with 0. A of first row, second column. And then for this, A of second row, first column. It's 0 we have to write. A of second row means here I'm just telling you about the index. 2 and then 1. What will be the value for this? A of 2 and then 2. So how we have to write the matrix indexing is this one. A of row and then column. Right? This is how you have to write. Since the indexing will be starting from 0, all the values will be minus 1, minus 1, minus 1. That's why we got here. Since the row is 3 only, but we will write it as 2 because we will start from 0. This is what I'm telling. Now we want diagonal numbers, right? So what are the diagonal numbers here? We'll take one color. I'll just highlight with this. 1, 5, and the next one is 9. So these are one diagonal elements, right? Okay, this is taking only some color. Okay, let that be. And what the other diagonal? 3. So I'll do it with some this color. And then 5 is already we have included, but still we will get 5 here also. So I'll just color with this, highlight with this. And then 7 is the other one, right? So what are the one diagonal is 159 and diagonal 2 is 357. So how you have to write the code for first diagonal? For first diagonal, elements are 1, 5 and 9. And for second diagonal, the elements are 3, 5 and then 7. So now what we have to do? Difference of first and second. That means first diagonal minus second diagonal. This is what we have to do in this question. Now everything regarding the question is clear. Now how you have to take the position of these elements, since we already wrote the 0, 0, 0 and all these positions 0, 0, 1, 1, 2, 2. So if you observe the pattern for these diagonal elements, row value and the column value are same, right? So what we can do while finding the sum of first diagonal, we can take condition like if row is equal to column. That means if the I value and the j value are same, then you have to add the element. That means if the row and column are equal, then you have to add that element to the sum. So only these diagonal elements we have the same pattern. So we can just go with this logic, row equal to column. So this is how we will get the first diagonal sum. Now how you have to take for the second diagonal? Now let's observe the pattern here. It's 0, 2, 1, 1 and 2, 0. So there is nowhere logic that this type of thing, row equal to column. So even row not equal to column, if you take, all are not equal to column only. So how you have to take? So let just work with small thing. Add row and column 0 plus 2. What is the value? 2. Add these two, 1 plus 1. I mean row and column. 1 plus 1 is also 2. And 2 plus 0 is 2. Okay, we have got one pattern here. So all the diagonals elements are 2 only. Okay, let's check with the other. 0 plus 1 is 1. So not equal to 2. 1 plus 2 is 3. So 2 plus 1 is 3 and 1 plus 0 is 3. So this diagonal also having one more pattern, which is sum of the row and column is same. Now here in this case, since we know the size of matrix, we are saying it 2. Then if the size of matrix is unknown, then how it will be? So let's just see with the size of matrix. What is the size of matrix? 3. So what is the sum of this row and column? 2. That means size of the matrix minus 1. So how you can write here condition inside this? If row plus column equal to size of the matrix. Okay, size of the matrix minus 1, then you have to add these elements. So there is one pattern for this diagonal and the other pattern for this diagonal. So we have got both the diagonal sum. Then you have to just make the difference. This is simple. So only you have to know how to frame a logic, how you have to observe the patterns here. That is the most important thing. So now let's go to the solving. We have a clear description. So let's solve this question now. Let me just go side by side. So I have chosen C as a default programming language, and then here you have to complete the logic completely and ignore this main part. This is completely given by the editor only. So for in the explanation we have taken it as rows and column, but here they have given us this array underscore rows, so arrays underscore columns, and here its ARR is array. We have double pointer, one is for rows and the other one is for columns. So now what you have to do, first let us take int I comma j for iterating. Okay, I is for iterating the row and j is for iterating the column. And how next we will take sum of first diagonal as sum1. I already mentioned that whenever you are doing sum or reverse or difference, initialize the values with the 0, because you will not get any garbage values. And let's take sum2 equal to 0 for the second diagonal, and diff, let's take it in short as diff equal to 0 for difference. Now what you have to do, you have to write the for loop. For I equal to 0, I less than, we don't know a number of rows, right? So they have passed it as argument, and then I plus plus. Okay, we have chosen one row. Now here why we should write for loop for the column thing also, because see, while iterating we have row and column. Now for the first for loop we are just iterating the value for only this, then we should get this value also, right? Only then we will get the value here. So we have to write one more for loop for this column also. So how you have to do? For j equal to 0, j less than columns, then j plus plus. Okay, now we are finding the first diagonal sum. Okay, let me add a comment here. So this is what first diagonal sum. Yeah, so what we have discussed here, logic is if row equal to column. That means what is row? We are giving row as I and column as j. You should not equate this array of rows. Why? Because this is just the count of number of rows and columns. So actual row is I here. So if I equal to j, what you have to do? Sum1 equal to sum1 plus array of I and j. Okay, this is how you have to write. So now this complete for loop, what it will do is it will find the sum of first diagonal, then second diagonal sum. Let me just copy this whole thing here. It will be same except that if logic. So what the if condition here it will be sum 2, okay, because we are finding the second sum and we declared it as sum 2. Now what the if condition will be here, we have already discussed. It is if row plus column is equal to size of the matrix minus 1. Size of the matrix here, since rows and columns are equal, we can just go with any of the number of rows or number of columns. So what we have to take, if I plus j equal to ARR underscore columns. So we can also choose here ARR underscore rows, because this is a 3 by 3. That means same number of rows and same number of columns, and we know that count from the parameters. So you can just go with any one here, and we have calculated the second diagonal sum. Now how you have to do difference, DIF equal to, now generally we do sum 1 minus sum 2. So what if we get negative numbers? So we have one function for that, ABS. So ABS means absolute, yeah. Even if you get negative number, it will just convert that to a positive number. So that is how this function works, ABS, okay. Now what you have to do, return diff. So we are returning the value of the difference. So we have written the complete logic. Now let's just check for that. Okay, wrong answer. Okay, I got it. So here it's array of columns minus 1. We have forgot that. So we have discussed here size of the matrix minus 1. I did not write that minus 1 here. That's my mistake, sorry. Let me execute it again. Yeah, it passed now. Let me submit the code as well. Yes, we have earned. So this is how you have to do, and how you have to find the patterns for a particular given question. So this way you have to find easily. First you have to go through the question clearly and then try to find the patterns in it and then write logic for that. So this is the complete solution for this problem, and let's see a few more questions in the coming videos. Thank you.